Hello.
Yep.
I need to tell you something, Che.
Yeah.
If you don't mind, right, Che, because I think maybe I might slack off with some previous chapters and I think I want to start over revision all again. So maybe there might be a time that in case when I do back the Latian, right, Che, then if I don't understand this, I might ask you, Che, no problem, right?
No problem. You want to ask question, we can answer you. No problem. Anytime you.
Like in that half an hour period every day, right?
As long as it's less than half an hour, 20
Yeah,
minutes,
yeah, yeah.
okay. Yeah.
So just
Okay.
give me 30 seconds, Che.
Okay. Let's carry on. And I can give you your first assignment. Treat it as a home take-home test. You can refer to your note, but don't go and check. Don't Google to find the answer. It's up to you. You don't do it, you lose. You are the one that lose, not me. I do my part.
Hello?
Yeah. Let's carry on.
Yeah, okay. Yeah.
Okay. Let's try number 3. The circuit diagram shows a potential meter. Length of the slide wire is 1 meter and its resistor is 2 ohm. Battery of EMF that has negligible internal resistance. The resistance of R is 2.4 ohm. Find the balance length. Okay? So before you can find this balance length, you have to find the PD across AB is normal equals to 4 volt. Because now the PD is shared between R and VAB. You have to find the potential difference across VAB. Okay, so you can represent this as your R and then VAB as your R2.
What happened, Jeff?
Something went wrong. My share, maybe I've pressed some wrong button. Okay, so we want RAB and then R2 is your R. That's your first step. Right? Potential across here is RAB, that's all. And this is your 4. 4 is across this whole thing. So RAB across this whole thing, total resistance. And your VAB, take the 4 across there. Put in your value. RAB, your total is 2 ohm. Hey, have I done something wrong here?
Yeah, you're supposed to start from A. I mean, like question A, you went to question B straight away.
What have I done? RAB is 2 ohm.
Che, there is A section, B section. You went to B straight away. A not che.
Oh, what have I done? Have I done something wrong here? Oh, A is here, sorry. Okay, we have to determine your VAB first. So you can replace this one. That wire with that resistance. And then there's your resistance there. So find your VAB first. Use your potential divider formula. Right? Potential across VAB over that is just RAB against that total resistance. Is the 4 there. And then you get 1.82. After you have found VAB, then you apply again. Right? AC over AB equals to AC is across is 1.5. AB is here. Yeah. Cross multiply, you get the answer. Okay. AB is 100 cm. So you get cm, your answer will be cm. You put meter, the answer will be meter. Can?
Can.
Okay.
Sure.
Okay, let's go to the next topic. Next part. The resistance R of the rheostat is changed to 1 ohm. Right? This one changed to 1 ohm. The cell of EMF 1.5 volt. And the governor are removed and substitute with a voltmeter of resistance. Right? This one becomes a voltmeter. And you have a resistance 20 ohm. What is the voltmeter reading when the slider touches the midpoint of AB? Okay, so same thing. Right? You want to find across VAB first before you can do the other, find the balance length, VAB. So VAB over that 4 there. Right? Remember this is now 1 ohm. So RAB over RAB is what?
So just now was VAB over 1.5, right?
Just now was 2.4. This one. Now you have changed it to 1 ohm. Okay, same formula, same formula. Right? Take your 4 across there. This one is still 2 ohm. Right? 2 ohm there. So that's 2 ohm plus your 1 ohm. 1 ohm for this one. Okay, so you get 2.67. Then you can find the balance length there and the voltmeter reading. Right, so effective resistance of RV or the voltmeter and RAC. Right, I'm just replacing that. Right, that one is your that one. Right, VAB. And then this one is 1 ohm. Right, RAC is 1 ohm. Remember that you want midpoint. And the resistance of AB is 2 ohm. So half of 2 ohm is 1 ohm. Right? RCB, the other part of the wire, right, represented as a resistor. So that one is also 1 ohm. And then this one is voltmeter is 20 ohm. Okay. Then you can calculate it. Right? 2.67. Replace these two. Replace these two. Right? RV. Right? Effective resistance of these two. These two together in parallel. This is still 1 ohm. Right? So that RV is just your, this 20, this is 1. Right? 20 times 1, 20 plus 1, or you can use your reciprocal. So I say, you remember this formula is easier. You multiply, and bottom there is plus there to find your effective. If not, you can use your reciprocal. After a car RAV, then you can calculate your voltmeter reading across here. Right? V, voltmeter reading over this whole thing is this one over the total resistance. Can?
Can.
Okay, I think we will jump to some other question. As I said, these are questions you should have been doing it yourself, learning yourself. Not everything I show you. Okay, let's try this question. Let me just remove the answer. Okay, potential meter shown in diagram below is used to determine the EMF and internal resistance of the cell. The battery E1, that one, has 2 volt. It has negligible internal resistance, so you don't have to worry about that resistance. The slide wire AB, right, 100 cm with a resistance of 5 ohm. That one is 5 ohm there, VAB, RAB. The resistor R1, so R1 is 2 ohm, R2 is 4 ohm. That one. The balance length for the wire is 85 cm. When the switch is open, when that switch is open, right, you basically going to measure your E2, and the balance length is 75 cm. When the switch is closed, and this one is closed, we are measuring the potential difference across here. Okay, determine the EMF of the cell E2. Same thing as I say, potential. First, find the potential difference across VAB first. Right? So VAB over that 2 is just that 5 there over these 2 add together. And you can find your 1.43 across VAB. Then you can find your EMF. Use right? So you want to determine the potential difference per unit length. So you just divide this one, divide by the balance length. Right? You have 1.43 is this whole length. So you divide by 100. So that's what you get. Determine the EMF of E2. Right? Same thing, E2 over VAB that we have calculated out here. Or you can use this one to calculate if you want to. Same thing. It's 85 over 100. Take this one across there. This one is 1.43 and 0.85. Okay. Last part will be find the internal resistance of this EMF. Yeah. Let me just remove the okay. You want to find your potential, find the internal resistance of the cell, of this cell there. Right? So now we are looking at this one. E2. I think I've done something wrong. Sorry. Yeah. We have to start with here first. This part. We have calculated E2. Now we want to find
That's the EMF one, right? Sir?
Yeah, EMF E2 we have calculated earlier. Yeah, that's your part 1. Right, then we should start from here. V2, that's your V2. When you close the switch there, V2 over your VAB. Right, not across here. You have to find VAB, that's what we are doing. Is 75 over 100. And take this VAB across there. So it's 75 over 100. Right, and your, let me see, have I done something wrong here? done something wrong here, sorry. Can see the mistake or not?
No, sir.
Eh, this one should be E2. That's why I got a mistake there. Eh, 1 to 1. Sorry. 1 to 1. You do the calculation again. One point two one times 0.75 9008. Zero point 9008. Okay, if I got that one wrong, this one will also be wrong. 0.9008 divided by 4 divided by 4 equals to 227. 227. Okay, so far? Let me just change the thing. Sorry. Have to do all the correction first. E2, this one should be 227. I got the wrong answer. Let me just check the calculation. 1.21 minus 0.908 equals to divided by 0.227. It's wrong. Okay, I think we will leave this one out. We have done some mistake there. So rather than spend the time doing all that correction, you can check yourself if you want to. Right? Basic is correct. E2 over VAB is just 85 over 100. And we take this VAB across there, it's 1.43 times 0.85. Got that? There's a part 1 there. Part 2 is just your balance length is now different, 75. So you're finding your V2 when you close the switch there over VAB. Right? So your E2 okay, the mistake may be here. Anyway, it should be VAB. VAB is 1.43 here. Okay, you can just go and calculate yourself. Idea is correct. Calculate I2. After you calculated your V2, you can calculate your I2 is V2 over R2. Okay, I'll just do the recalculation. I'll go over with you next week. Okay, you can use this equation to calculate E2 over V2 faster rather than do all this too slow. Then you look at this circuit there, forget about that. No current passing through here. So E2 is just your V2, I2 times R inside there. And then you take this over E2 minus V2 divided by your I2. Okay, so you just go back and check. Okay, we'll go over with you next week. Let's try one last one, then we go to a long question. Which bridge shown in diagram is used to determine the resistance R of a resistor? The center zero counter is balanced. What is the value of R? Right, so it's balanced R over A is 20 over 5. Right, that one you must remember. There, take the 8 across there, got that, and use your calculator. Can?
Can.
Okay, you won't bother about this one. Let me see what I've done for you enough already. Okay, let's try number 8. Okay, in the meter bridge shown, the resistance P and Q are 5 and 3 ohm respectively. When the length of wire is connected parallel to P wire, the balance length is that length there, 0.527 meter from A. What is the resistance of the length of wire? Okay, so we can find the total effective resistance here. Right? It's in the same formula. Let R be the resistance of this wire. X is the resistance of these two, P and R. So X over Q is 52.7. I change to cm. Right? This is 100. That length is 100 minus 52.7. Then calculate your X. Then you can use your reciprocal formula. Right? 1 over X equals to 1 over R plus 1 over P. Right? I just take it across there, that's all. And calculate out, put in your value. Calculate your R. Okay. Any problem?
No.
If the wire is of length 0.75 meter and diameter is that, calculate the resistivity of the wire. This one, they want you to remember the resistivity formula. Right? Two topics together, the previous topic and this topic combined. Remember the formula? Put in your value for resistance. That one. Pi for area, pi, that's your R, right? You are given that one, diameter, so you divide by 2, change it to meter, and then square the whole thing, right? This is your R square. And then L, that one there. Okay. Ohm meter. Okay or not? Anything not clear?
Yeah, okay.
Okay, we are okay. Let's go to a long question. Teach you how to answer that. All right, let's try number 15. You just get rid of all the answer first. No, I don't think. I think we'll do essay. Sorry, no point in going over all that again. This one you can do yourself. Don't know, you can ask me next period. Teach you how to answer long question. Okay. Take Kirchhoff's law of electric current. Right? Memory work. That one you must score. Can remember Kirchhoff's law? Yeah.
Angel,
Okay, tell me.
they want the first one or second one?
They say state Kirchhoff's laws. So it means both first one and second one.
Oh, okay. Kirchhoff's first law is the algebraic sum of the current entering a point in a circuit that is zero.
Okay. The sum of current at a junction is zero, not a point, junction. First law states that the sum of current entering or equals the sum of current flowing out. Okay, second law.
Kirchhoff's second law is the algebraic sum of the product of the current and resistance equal to algebraic sum of the EMF in the loop.
Second law states that the closed loop is important. Sum of EMF
Closed loop.
equals sum of PD. Okay, what are the fundamental laws associated with Kirchhoff's law? Right, in case it got cut off, remember we have to start a new Zoom.
Yeah.
Yeah, what are the fundamental law for the first one? Conservation of what?
Conservation of charge.
Okay, good. Second one?
Conservation of energy.
Conservation of energy. Memory work. Okay, we've done that. A. Now let's go to B. Right, 2 cell, EMF 1.5, 0.5 ohm, and EMF 3 volt. Internal resistance 1 ohm. Respectively are connected to 3 resistors. These are the 3 resistors. find the current I1, I2, I, right? They're kind enough to give you the direction of the current. So you just apply Kirchhoff's current law, first step, right? I is the one coming out, I1, I2 is going in, I1, I2 going in, that's the first one. Then after that, choose your loop. There are 3 loops that you can choose, right? V, A, B. I'm choosing V, A, B, C, F, this one. So A, B, C, F, I'm choosing it, I'm taking it anti-clockwise, right? Because I'm the one to vote with positive, the one negative answer. That's the reason. Right? So it's 1.5, 1.5. And these two total resistance is 2 plus 0.5 is 2.5 times your I1. And then this 5 times your I. Okay, I got that. Then I just divide by 5. Simplify it first. So this becomes 0. Divide by 5 is 0.3. Divide by 5. This one becomes 1. By 5 is 0.5. Then I take the loop E, D, C, F, right? Clockwise. So I got your 5 times your I plus your 4 times your I2. What have I done? I made a careless mistake again. Oh, sorry. 4 plus 1 is 5. Right? 5 times your I2. And then this is 5 times your I. Right? I shorten the step. These two resistors add together, because the same current pass through them. Right? Then I'm replacing the I here with this one. Sorry, I'm replacing I2 because I want to calculate this one. So I'm replacing your I2 from here. Take this across there. I minus I1. So replacing my I2, 5 times that. Okay. Yeah, that I2 there, this one, place it inside there. So I got 5I, 5I plus 5I is 10I. Then 5I1, 5I1, that's your 3. Okay. It's all more or less already. Number 1, 3 plus 2. Equation 3 plus 2. I have I done again. Have I done? Have I done? 3 plus 2. 3 plus 2, I cannot add these two together. I have to multiply this by 10 first. Okay, looks I'm careless again. That one should be, I think we might as well correct for it. This one, times 5. That equation multiply by 5. So I get 5I Sorry, I'm getting a bit careless these days. Five I, sorry, times 10. Yeah. Then I plus 1.5. So now I get this is my equation 2. So 2 plus 3, 2 plus 3, these 2 will go off. So I get 20I 20I, so 20I 3.3 divided by 20. Okay, so I got my I. After I got my I go to the second equation, this one. Okay, or we can use this one. 0.I1 is 0.3 minus I. It looks like this one is wrong again. One, 3, 5. Then our I2 we can get it from here.
Teacher, the Zoom thing going to finish.
Yeah.
Less than 1 minute.
Yeah. So stop here. You can go back
Okay.
and tidy up the answer. My carelessness. Check properly.
Okay.
So in the next period,
Okay.
we will start with our new topic. The rest,
Okay.
I'll send you the assignment soon.
Okay.
Okay, we can take a break. We'll stop here. Thanks.